You look up at the night sky and see nothing unusual, just stars. But on the morning of November 10th, 2025, telescopes in Italy caught something that had been invisible for weeks, a faint streak of light trailing behind a visitor from another star system. The interstellar comet 3I Atlas has emerged from behind the Sun with a tail that astronomers can now see from Earth. And what that tail reveals changes everything we thought we knew about objects from beyond our solar system. 4 months. That is how long scientists have been tracking this cosmic intruder. July 1st, 2025. The Atlas telescope in Rio Hurtado, Chile, spots something moving through space at 210,000 kilometers per hour. Fast, too fast to be one of ours. The trajectory is hyperbolic. That word means escape velocity. This object did not form around our Sun. It came from somewhere else in the galaxy, potentially 7 billion years old, twice the age of Earth itself. The third confirmed interstellar visitor in human history after 1I Oumuamua in 2017 and 2I Borisov in 2019. They give it a designation. 3I Atlas. The I stands for interstellar. If you value documented space and astrophysics history like this, subscribe. It is the best way to support our work. Also, comment from which city you are hearing this from. Also, this script is researched and factual, using sources from the Virtual Telescope project in Manciano, Italy. Published November 11th, 2025, showing ion tail development, Nature Astronomy. Peer-reviewed study from August 2025 on chemical composition, and NASA JPL Small Body Database with orbital mechanics updated November 12th, 2025. Now back to the information. Pre-discovery images push the timeline. Back further. Zwicky Transient Facility finds it on June 14th, 2025. Atlas catches it on June 5th. Pan-STARRS has frames from May. And the TESS spacecraft sees early cometary activity on May 7th, when the object is 6.4 astronomical units from the Sun, farther than Jupiter, already outgassing, already active. Something is sublimating off its surface, billions of miles from the heat source. That should not happen, not at that distance. But it is. The detection itself was no accident. Atlas system uses 4 telescopes scanning the entire visible sky every 2 nights, hunting for asteroids that might threaten Earth. On July 1st, the Chile facility flags an object, moving fast, wrong direction. Amateur astronomer Sam Dean notes, Atlas had additional pre-discovery observations from June 5th through 25th, but the comet was not discovered earlier because it passed in front of the galactic center dense star fields. Too many stars, too much noise. The comet blended in. Only when it moved away from that crowded region did the automated detection algorithms flag it as unusual. Within hours of the initial report, professional and amateur astronomers worldwide began follow-up observations. Lowell Discovery Telescope in Arizona, Canada-France-Hawaii Telescope at Mauna Kea, Deep Random Survey in Chile, all confirming it. Not an asteroid, a comet, with activity, with coma. July 2nd, 2025. Minor Planet Center collects 122 observations from 31 different observatories. They officially announce the discovery. Designation: 3I Atlas, the third interstellar object designation ever issued. The first 2 were 1I Oumuamua and 2I Borisov, now 3I. The letter I separated from humanity objects from the rest. Everything else gets different designations: numbered asteroids, periodic comets, non-periodic comets from our system. But interstellar objects get the I Special category, visitors from beyond. The size estimate comes from Hubble Space Telescope images on July 21st, 2025. The nucleus measures somewhere between 1,444 feet and 3.5 miles across. Small for an interstellar object. Oumuamua was maybe 300 to 3,000 feet. 2I Borisov was under a mile. 3I Atlas sits in the middle. Not massive, but moving with incredible speed. The mass loss calculations from NASA Jet Propulsion Laboratory show non-gravitational acceleration. Translation: this comet is changing velocity without. Gravity causing it. Something is pushing it. Gas jets. Material ejecting from the surface at high speed, creating thrust like a rocket engine. The normalized acceleration at 1 astronomical unit from the Sun is 1.07 times 10 to the negative 7 meters per second squared. Small number, big implications. Hubble images reveal more than size. The nucleus appears surrounded by teardrop-shaped cocoon of dust, material streaming off the surface. The wide field camera captures the structure in detail. David Jewett from UCLA leads the observation team. The images show the dust tail extending away from the nucleus, faint, broad, curved slightly by the combination of orbital motion and solar radiation pressure. The teardrop shape tells us the dust particles are being blown away continuously, not in sudden burst. Steady outgassing, constant sublimation. The nucleus may be rotating, causing different areas to face the Sun at different times, creating the asymmetric dust distribution. Background stars appear as streaks because Hubble tracks the comet as it moves against the starfield. 21-minute exposure. The comet travels noticeable distance in that time. The tracking keeps nucleus sharp, while stars trail behind painting lines across the frame. July brings the first spectroscopic data. Gemini North Telescope in Hawaii turns its multi-object spectrograph on the target. The coma glows green. That color signature is carbon-2 molecules, diatomic carbon, but there is more in the mix. Observations from multiple observatories using the Very Large Telescope in Chile reveal nickel vapor in the gas surrounding the comet. Not a little nickel, a lot of nickel. Shivan Rahatgaonkar and Baltasar Luco from the Instituto de Astrofísica Pontificia, Universidad Católica de Chile, measure it across multiple days. As 3I Atlas moves closer to the Sun from late July through August 2025, nickel levels increase. They use spectrographs looking at light characteristics. The nickel-to-iron ratio is wrong. Most solar system comets show nickel and iron together in roughly solar proportions. Both metals release from organometallic compounds that sublimate at low temperatures. 3I Atlas shows strong nickel emission but weak iron. The ratio normalizes as the comet approaches perihelion, but the early imbalance is puzzling. August 6, 2025. James Webb Space Telescope points its near-infrared spectrograph at 3I Atlas. Distance from Sun, 3.51 astronomical units. What JWST finds stops the astronomy. Community cold. Carbon dioxide to water ratio of 8:1. Among the most extreme ever measured in any comet. The number exceeds the expected trend for its distance from the Sun by more than 6 standard deviations. Solar system comets typically show significant water vapor relative to carbon dioxide, especially at similar distances. 3I Atlas is carbon dioxide rich and water poor. NASA SphereX mission from August 7th through 15th, 2025 corroborates this. The spacecraft images a vast carbon dioxide coma extending at least 348,000 kilometers. No comparable water cloud detected. The water that is there comes from NASA Neil Gehrels Swift Observatory, detecting hydroxyl gas on October 7th, 2025. Hydroxyl is the chemical fingerprint of water. Swift spots a faint ultraviolet glow that ground observatories cannot see. The water loss rate, 40 kilograms per second. But here is the problem. Swift detects that hydroxyl when 3I Atlas is nearly 3 times farther from the Sun than Earth. That should be far beyond the distance where water ice on a comet's surface normally turns into gas. Something is keeping the water locked inside while carbon dioxide escapes freely. 2. Theories emerge. Formation zone or surface crust. First theory, 3I Atlas formed near its parent star carbon dioxide iceline, where conditions favor condensation of carbon dioxide over water. If the comet formed in an environment colder than Earth, but warmer than typical icy regions, carbon dioxide could freeze more readily than water. Second theory, a dusty or insulating crust on the surface prevents warmth from penetrating. Water ice stays locked below. Carbon dioxide escapes through cracks or thinner spots, Both scenarios hint that comets from other star systems may be chemically and structurally different from anything in our neighborhood. The trajectory brings it close to Mars on October 3, 2025. Closest approach, 0.19 astronomical units, 28 million kilometers, 18 million miles. European Space Agency Mars Express and ExoMars Trace Gas Orbiter both observe it. ESA ExoMars TGO uses its color and stereo surface imaging system, capturing 5-second exposures. The comet appears 50,000 times fainter than what the orbiter normally views. But they get images. China Tianwen-1 Mars probe also captures frames. All 3 spacecraft see 3I Atlas in the Martian sky as background stars streak past, because cameras are tracking the fast-moving comet. This Mars encounter provides unique perspective. From Mars, the viewing geometry differs from Earth. The spacecraft see the comet from different angle, revealing details Earth-bound telescopes cannot capture. ExoMars TGO images show the coma structure. The nucleus too small to resolve at that distance, but the surrounding cloud of gas and dust clearly visible. Background stars appear as streaks because the camera tracks the comet motion across the sky. 5-second exposures, long enough to collect photons from faint target, short enough to keep the nucleus from smearing too much. The engineering team calculated the exposure time carefully. Too short and you get nothing. Too long and the comet movement blurs the image beyond usefulness. 5 seconds. Perfect balance. Mars distance at that moment, 0.52 astronomical units from Sun. 3I Atlas at 0.19 astronomical units from Mars puts the comet 1.3 astronomical units from the Sun, still approaching perihelion, still brightening. The spacecraft observations provide ground truth for brightness models. How bright should comet be at that heliocentric distance? Models predict one value, observations show another. The comet outperforms expectations, more active than predicted, releasing more gas and dust than models suggested. The discrepancy matters because it tells us the comet nucleus is more volatile rich than assumed. More ices near surface ready to sublimate, more material ready to lift off when sunlight hits it. Then comes the disappearing act. October 30th, 2025 at approximately 0400 Coordinated Universal Time. 3I Atlas reaches perihelion, closest point to the Sun, 1.4 astronomical units, 210 million kilometers, 79 million miles, but from Earth you see nothing. The comet sits behind the Sun in the daytime sky. Solar. Glare blocks all observation. Space-based solar observatories catch glimpses through coronagraphs. SOHO LASCO C. 3 clear images. Stereo, core, 2 frames. Stereo, shy 1 data. The comet brightens rapidly and unexpectedly during perihelion passage. Magnitude predictions said it would peak around 11.5. Instead, observations show it reaching magnitude 9.9 to 10. Almost 2 full magnitudes brighter. The brightening is not gradual, it surges. Unistellar Network citizen astronomers measure photometric data showing an unexpected jump in brightness just before the comet becomes unobservable. The surge continues through perihelion per space-based observations. Scientists debate what is happening. Sudden outburst, increased surface activity, or is something else occurring while we cannot watch? From October 30th through early November, the comet remains hidden from Earth. Only spacecraft observations provide data. Europa Clipper and Hera spacecraft are predicted to potentially pass through the ion tail of 3I Atlas from October 30th to November 6th. Ion tail immersion. Characteristic changes to solar wind, magnetic draping structures. NASA predicted this. Whether the spacecraft detected these signatures remains under analysis. November 5th, 2025. Arnaves Observatory in Spain releases post-perihelion images. The frames show a compact source of light, fuzzy ball. No obvious cometary tail pointing away from the Sun. The coma morphology looks similar to Hubble Space Telescope images from July 21st. Avi Loeb from Harvard publishes an analysis on Medium. He points out the lack of clear tail structure, despite NASA JPL reporting non-gravitational acceleration, showing mass loss of more than 13% during perihelion passage. For a typical comet, that mass loss should create a massive coma, with dust and gas pushed by solar radiation pressure and solar wind into a visible tail pointing away from the Sun. That tail should be obvious. But the November 5th images show no such feature. For comparison, Loeb includes an image of Comet Lemon from November 3rd, 2025, also taken by R. Naves Observatory. Lemon displays a clear cometary tail streaming away from the Sun. Expected behavior. 3i Atlas does not. The debate ignites across astronomy communities. Forums fill with speculation. Is 3i Atlas fragmenting? Did the nucleus break apart during perihelion? Is this normal comet or something else? Social media amplifies the questions. Some point to Loeb prior papers suggesting technological origin. Others dismiss that, citing lack of evidence. The scientific consensus leans toward natural explanation, but the missing tail remains unexplained. Where is the material that should be streaming away? Did it dissipate? Is viewing angle hiding it? Or did something unexpected happen during the solar approach? If you value this kind of documented astronomical research and real-time science coverage, subscribe. It helps us continue bringing these stories as they develop. Comment where you are watching from. This script uses peer-reviewed sources, including the archive preprint from Chicheng Zhang published October 25, 2025 on rapid brightening observations, and Meerkat radio telescope detection data from October 24, 2025 published in Astronomer Telegram, backing every claim with actual observations from professional observatories and space missions. Now back to the comet. November 6th. Virtual Telescope Project in Manciano, Italy, also releases images. Compact nucleus. Minimal tail structure visible. Debate intensifies. Some claim the comet is not behaving like a normal comet. Others point to viewing geometry. When a tail points directly away from or toward the observer, it can appear foreshortened or hidden. The anti-solar direction from Earth perspective in early November may align with the tail, making it difficult to see, even if present. Then November 10th arrives. Virtual Telescope Project astronomer Gianluca Masi combines 14 exposures of 120 seconds each. The comet sits 12 degrees above the eastern horizon. Moon phase, 71%. Bright moon, 85 degrees away. Difficult observing conditions. But the image shows something new. An ion tail, faint but visible, pointing northeast. The geometry has changed. As 3i Atlas moves into the morning sky, the tail, which was behind the nucleus as seen from Earth at perihelion, now becomes visible. Not a trick of light. Real structure. Real evidence of cometary activity. Masi uses robotic telescopes at the Virtual Telescope Project facility in Manciano, Italy. Artec 250mm aperture telescope, Paramount ME mount, C3 Pro 61000 EC camera. The system operates remotely. Masi programs the coordinates. The mount slews to target. Camera starts exposing. 120 seconds per frame, 14 frames total, 28 minutes of integration time. Each exposure captures photons from the faint comet, background sky glow from moon, light pollution from distant towns, atmospheric turbulence, all of it recorded in the sensor. Then comes the processing, sigma clipping combination method. The algorithm compares all 14 frames, identifying cosmic ray hits and satellite trails and other artifacts present in only 1 or 2 frames. It removes them, combines the good data. The result, clean image showing the comet coma and extending from it that faint ion tail reaching into space. The tail direction matters. Northeast, not directly away from Sun. The geometry creates angle between anti-solar direction and the actual tail because the dust and gas left behind along the orbit curve in space. The ion tail points almost exactly anti-solar because the solar wind moves much faster than the comet. The ionized gas gets blown straight back. But from our viewing angle on Earth, the tail appears to point northeast because of the 3-dimensional geometry. We see the projection on the sky, The true direction in space differs from apparent direction as viewed from our moving platform orbiting the Sun. November 11, 2025, 18 more exposures, 120 seconds each. Comet 14 degrees above eastern horizon. Moon 61% illuminated 70 degrees away. The ion tail is longer, more defined, spanning at least 0.7 degrees. Northeast direction. An anti-tail also appears pointing east-southeast. Multiple tail structures. Jets. Complex morphology. Michael Yeager, Gerald Rehman and Enrico Prosperi share images on November 8th through the ICQ Comet Observations Facebook page. Their frames show 4 to 5 tails or jets fanning out in multiple directions. Not a single stream. Multiple plumes. The nucleus is actively ejecting material in various directions as it spins. Images from British Astronomical Association members on November 9th show large-scale jet structure, including sunward anti-tail features. These anti-tails are not optical illusions. They represent dust sheets that align with our line of sight, creating a spike-like appearance pointing toward the Sun. Why the tail was invisible and now appears comes down to geometry and timing. During perihelion passage, the tail extended away from the Sun, but from Earth perspective, it pointed almost directly away, creating a foreshortened view, mostly hidden behind the coma. As 3I Atlas emerges from solar conjunction and moves into the pre-dawn sky in November, Earth viewing angle changes. The tail structure that was edge-on becomes visible at an angle. The ion tail is sculpted by solar wind. Charged particles stream from the Sun, hitting the ionized gases in the coma and pushing them into a narrow stream pointing directly away from the solar direction. Dust tails are broader because dust particles respond more slowly to solar radiation pressure and spread out more. 3I Atlas shows both. The chemistry story gets more complex. October 24, 2025. Meerkat Radio Telescope Array in South Africa detects hydroxyl radical absorption lines at 1665 and 1667 MHz. First radio detection from an interstellar comet. Hydroxyl traces water vapor. Earlier attempts in September failed. The detection confirms water is present and sublimating. But the radio signal reveals something else: hydrogen cyanide. James Clerk Maxwell Telescope observes 3I Atlas on September 7th and 14th, 2025, when the comet is 2.33 astronomical units from Sun. Hydrogen cyanide production rate, 1.5 plus or minus 0.5 times 10 to the 25th molecules per second on September 7th. By September 14th, 4.5 plus or minus 1.9 times 10 to the 25th molecules per second, 2 kilograms per second. The cyanide coma on September 15th is approximately 180,000 kilometers across and asymmetric, elongated along the anti-solar direction. On the same date, a visible dust tail measures 50 arc-seconds across, corresponding to about 100,000 kilometers. Here is where things get strange. The gas plume composition. Studies using very large telescope spectrographic data show nickel to cyanide ratio orders of magnitude larger than all known comets, including 2I Borisov. The nickel content resembles industrially produced nickel alloys more than natural cometary ice. The gas plume contains only 4% water by mass, where most comets are water-dominated. The carbon monoxide levels indicate ongoing chemical evolution, not pristine. Composition. A paper examining spectra not yet peer-reviewed from astronomers in Belgium and USA suggests the substantial carbon monoxide and unusual carbon dioxide to water ratio may result from galactic cosmic ray processing. Over billions of years in interstellar space, high-energy particles bombard the comet's surface, altering the outer layers. Instead of pristine material from another star system, we may be seeing processed material shaped by the journey. The surface chemistry has been cooked by radiation exposure during transit through the galaxy, potentially for 10 billion years. The hydrogen cyanide detection itself matters beyond just identifying another molecule. Cyanide compounds represent building blocks of more complex organic chemistry. Amino acids form from cyanide precursors. Nucleobases in DNA and RNA trace lineages back to hydrogen cyanide reactions. Finding it in interstellar comet confirms these basic chemical building blocks exist beyond our solar system. The production rate increasing from September 7th to 14th tells us the nucleus is warming up as it approaches the Sun. More heat means more sublimation, means more molecules released into space. The asymmetric coma shape elongated toward anti-solar direction shows solar wind already beginning to push the gas away. Not full tail yet, but the beginning of tail formation. The process starting. This makes studying the environment of the parent star system more difficult. The outer layers conceal pristine material underneath, but it tells us about the interstellar medium, the journey, the conditions between stars. The tail growth documented from November 10th through November 13th shows increasing activity. Space.com reports on November 12th that the ion tail continues lengthening and sharpening. BBC Sky at Night magazine publishes on November 11th, describing the tail as getting longer with observations showing it spans at least 0.7 degrees and potentially more in deeper exposures. TechStock reports on November 9th and 12th compile multiple observer reports. Images show complex jet behavior, multiple plumes, anti-tail features. The nucleus remains highly active. What does the tail tell us? First, 3I Atlas is definitely a comet. Active outgassing, dust and gas ejection, tail formation responding to solar wind and radiation pressure. This is not Oumuamua with its strange cigar shape and no visible coma. This is not an alien spacecraft, despite speculation from some researchers. This is a comet behaving like a comet, albeit one with unusual chemistry. Second, the delayed tail visibility from Earth. Perspective was purely geometric. The tail existed during and after perihelion, but Earth viewing angle made it invisible or foreshortened until the comet emerged into the morning sky in November. Third, the tail structure complexity with multiple jets and anti-tail features indicates an active, irregularly shaped nucleus with multiple venting regions. As the nucleus rotates, jets turn on and off. Fourth, continued activity despite distance from Sun confirms volatile rich composition. The carbon dioxide dominance explains activity at large heliocentric distances. Carbon dioxide sublimates at much greater distances than water ice. The ion tail specifically reveals the comet interaction with solar environment. Ultraviolet radiation from sun strips electrons from gas molecules creating ions. Charged particles. These ions respond to magnetic fields embedded in solar wind. The solar wind is not just particles, it carries frozen in magnetic field lines from the sun. When comet coma intersects this magnetized plasma, the ions get caught and dragged along. They stream away from the comet in narrow beam pointing exactly opposite the sun. The beam can extend millions of kilometers. Sometimes disconnection events occur. When the comet crosses a boundary between different magnetic field regions in the solar wind, the entire ion tail can be severed. It floats away into space. The comet quickly grows new tail as fresh gas sublimates and gets ionized and caught by the solar wind. Comet Lemon experienced such disconnection event on October 2nd, 2025. 3I Atlas likely experienced similar events during perihelion passage, but we could not observe them from Earth because of the solar glare. The dust tail tells different story. Dust particles are not ionized. They are too massive for magnetic fields to affect significantly. Instead, they respond to solar radiation pressure. Photons from sunlight hit dust grains, transferring momentum. The pressure pushes particles away from sun, but dust particles have inertia. They do not accelerate instantly like ions. They gradually drift outward, while also continuing to follow orbital motion inherited from parent comet. The combination creates broad curved tail. Larger particles drift slower, staying closer to nucleus. Smaller particles accelerate faster, spreading out wider. The size distribution of dust creates the breadth of the dust tail. Analyzing tail width and structure tells us the size range of particles being ejected and how much force required to lift them off the nucleus surface. The orbital mechanics seal the fate. 3I. Atlas is leaving, forever. Traveling at approximately 30 kilometers per second, fast enough to escape solar gravity entirely. December 19, 2025. Closest approach to Earth at 1.8 astronomical units, 270 million kilometers, 167 million miles, still far. Too far for naked eye observation, but accessible to amateur telescopes and cameras. The comet will reach magnitude 11 to 12, faint, requiring at least 80 to 150 millimeter telescope under dark skies. By end of December, fading to magnitude 13, March 16, 2026. Passes 0.36 astronomical units from Jupiter, 54 million kilometers. Then beyond planetary region of solar system, by early 2030s completely gone from our neighborhood. Back into interstellar space. Silent voyage through galaxy continues. The data collection window closes fast. Every observation matters. ESA JUICE spacecraft currently en route to Jupiter, and its moons is attempting coordinated observations throughout November 2025, due to spacecraft geometry and limited downlink bandwidth near the Sun. JUICE data may not reach public archives until early 2026. ESA Mars Express and ExoMars Trace Gas Orbiter already captured views around October 3rd, Mars flyby. NASA Hubble captured sharp images July 21st. JWST obtained spectra August 6th. SphereX imaged the carbon dioxide coma August 7th through 15th. SWIFT detected hydroxyl in October. Ground-based observatories from Chile to Hawaii to Europe continue photometry and spectroscopy. Amateur astronomers with backyard telescopes contribute to unistellar network near continuous photometric monitoring. Michael Jaeger in Austria, Gerald Rehmann, Peter Horálek in Czech Republic, all capturing frames. The chemistry remains puzzle. Why such extreme carbon dioxide to water ratio? Why high nickel relative to iron? Why only 4% water by mass? The cosmic ray processing hypothesis, published November 8, 2025 on Archive, suggests billions of years of radiation exposure, altered surface composition. Paper by researchers examining JWST and SphereX data. Not peer-reviewed yet. The theory, rather than being pristine messengers from distant planetary systems, interstellar objects may carry signatures of processed material, shaped by gigayear scale cosmic ray exposure, both in distant reservoirs of parent stellar systems prior to ejection and during interstellar transit to solar system. If true, this complicates efforts to learn about other star systems from interstellar visitors, but it opens new avenue, studying the interstellar medium itself, the space between stars, radiation environment, chemical evolution during transit. Alternative explanations exist. Formation in unusual region of parent protoplanetary disk. Perhaps 3I Atlas coalesced in carbon dioxide-rich zone while water remained in vapor phase, or parent star system had different chemistry altogether, different elemental abundances, different ice condensation sequence. We sample one comet from one unknown system 7 billion years old. Generalizing is dangerous, sample size of 1. The anti-tail continues puzzling observers. Normal comets rarely show sunward-pointing tails. When they do, it is usually optical illusion from viewing geometry. Dust particles ejected previously along orbit appear to point towards Sun from certain angles. But 3I Atlas showed sustained sunward jet activity during July and August 2025 per very large telescope observations. Hubble images from July 21st show sun-facing plume, pointing right in frames. Images from July and August show changes in coma shape over time. Sun-facing plume visible in all images. This is not edge on dust tail. This is active jetting toward the Sun. Unusual but not impossible. Requires specific nucleus topography and rotation state. Crater or depression on sun-facing side venting material directly toward solar direction. Rare but documented. In some solar system comets under specific geometric conditions, the trajectory alignment raises questions. Avi Loeb points out the retrograde trajectory is aligned within 5 degrees of ecliptic plane of planets around Sun. Likelihood, 0.2%. Arrival time brought it within tens of millions of kilometers from Mars, Venus, and Jupiter, while being unobservable from Earth at perihelion. Likelihood, 0.005%. Nucleus is approximately 1 million times more massive than Oumuamua and 1,000 times more massive than 2I Borisov, while moving faster than both. Likelihood, less than 0.1%. Lobe suggests these statistical anomalies merit consideration of non-natural origin. Most astronomers disagree. Observations from Hubble's Sphere-X ESA Mars orbiters show classic comet characteristics: small, icy nucleus, carbon dioxide-rich coma, water vapor bursts, anti-tail from viewing geometry. Chemistry unusual but explainable through formation conditions or cosmic ray processing. No evidence of technological origin, no course changes, no directed thrust, no artificial signatures in spectroscopy. No signals detected despite radio observations. The first radio signal from interstellar comet detected October 24th by Meerkat represents breakthrough for radio astronomy. Unlike physical probes limited by time and cost, radio telescopes capture chemical signatures from afar. Observed hydroxyl patterns align with solar system comets. Differences help refine models of galactic evolution and star formation. Future research aims to detect hydrogen line emissions at 1,420 MHz, which could trace comet trajectory with greater precision. Meerkat detection after failed September attempts highlights challenge of observing faint targets. Success required precise timing when comet was active enough and positioned favorably. The November images showing tail growth changed the narrative. Initial post-perihelion frames without clear tail fed speculation about anomalous behavior. But improved viewing geometry from November 10th onward reveals normal cometary tail structure responding to solar wind, ion tail sculpted by charged particles, dust tail broader and curved, anti-tail from dust sheet alignment, multiple jets from irregular nucleus, all expected features of active comet. The tail was there all along, we just could not see it from our vantage point until the comet moved into morning sky. This is what science looks like. Initial observations raise questions. Incomplete data creates uncertainty. Speculation fills gaps. Additional observations provide answers. Geometry explained tail absence. Chemistry explained unusual composition. Activity level explained early outgassing. Rotation state explained multiple jets. Cosmic ray. Hypothesis explains surface processing. Patience and continued observation resolve mysteries. Not alien spacecraft. Ancient comet from another star carrying information about distant system and interstellar journey. The age estimate of 7 billion years comes from dynamical modeling. If 3I Atlas formed around parent star system, that old it predates formation of Earth by 2.5 billion years. Our solar system is 4.6 billion years old. 3I Atlas could have formed when universe was only half its current age. Primordial relic, time capsule. The materials locked inside that nucleus preserve chemistry from ancient epoch of galaxy. If we could sample it directly, drill core extract ice measure isotopes, we would read history book written before our world existed. But we cannot. The comet is too far. Moving too fast. By time we could launch mission to intercept it would be beyond reach. We get one chance. July 1st discovery, 5 months to perihelion, brief window of peak activity, then departure. All observations must happen now. Telescopes around world coordinate, space telescopes and ground observatories, and Mars orbiters and amateur astronomers all contribute pieces of puzzle. Global collaboration, international effort, amateur-pro cooperation. The comet will continue, fading through December. Observations will continue as long as possible. Spectroscopy to measure evolving composition as heliocentric distance increases. Photometry to track brightness changes and detect potential outbursts. Imaging to document tail structure and jet activity. Radio observations to detect hydrogen and other molecules. All data will be archived, analyzed for years. Papers will be published, theories will be tested. 3I Atlas will become benchmark for future interstellar object studies. Because more are coming, detection capabilities improve, surveys get more sensitive. Pan-STARRS, Atlas, Zwicky Transient Facility, legacy survey of space and time starting soon at Vera C. Rubin Observatory. These systems will find more interstellar visitors, maybe several per year. Each one will teach us something new about other planetary systems, about cometary chemistry, about galactic environment, about diversity of objects formed around different stars. ESA Comet Interceptor mission, scheduled for launch, will be designed to rendezvous with future interstellar object or long-period comet. Spacecraft will wait at Lagrange Point until suitable target appears, then maneuver to intercept. Direct measurements, close-up imaging, sample analysis, everything we cannot do with 3I Atlas, we might do with Next Visitor. But we needed 3I Atlas to learn what to look for, what instruments to design, what measurements to prioritize. The tail revelation from November 10th changes nothing about physics. Comets have tails. Solar wind pushes ionized gas into streams. Radiation pressure pushes dust. We knew this, but seeing it on interstellar comet confirms these objects follow same rules, same forces, same physics. They formed around different stars under possibly different conditions with different chemistry. But once in solar wind and solar radiation field, they respond predictably. Universal laws of physics apply universally: gravity, thermodynamics, radiation, magnetism. Same everywhere in galaxy. 3I Atlas proves it. The human story matters too. Shivan Rahatgaonkar and Baltazar Luco students observing with SOAR telescope in Chile, not expecting to find nickel but finding it anyway. Dennis Bodowitz from Auburn University team using Swift Observatory detecting hydroxyl against odds. Gianluca Masi from Virtual Telescope Project patiently imaging through moonlight and low elevation, finally capturing the tail. Qicheng Zhang from Lowell Observatory spotting the returned comet November 1st through thin clouds in morning twilight using 6-inch telescope. Amateur astronomers across globe contributing observations to Unistellar Network. ICQ Comet Observations community sharing frames and measurements on Facebook. This is collective effort. Nobody does this alone. On November 11th, 2025, when telescopes captured that ion tail stretching 0.7 degrees across the pre-dawn sky, we saw a visitor from another star behaving exactly as physics predicts. Sublimating ice, ejecting gas, responding to solar wind, forming tail. 7-billion-year-old comet from unknown parent star system, following same rules as comets that formed here. No mystery, no aliens, just cosmic wanderer briefly passing through our neighborhood, giving us glimpse of chemistry from distant part of galaxy, billions of years ago. The tail reveals truth. This is comet, ancient, unusual chemistry, but comet nonetheless. December 19th, it passes closest to Earth, magnitude 11 or 12, faint smudge in telescope. Long exposure photos will capture it. By end of month, fading. January 2026, nearly gone. March, passing Jupiter. Then darkness. Interstellar space. Next encounter with another star millions or billions of years from now. But for 5 months in 2025, humanity got to study it, measure it, learn from it. And when viewing geometry finally aligned in November, we saw its tail streaming behind it. Ion tail, dust tail, anti-tail jets, all working together, painting portrait of active comet from beyond. That November 10th image from Manciano, Italy, 14 exposures stacked despite bright moon, despite low elevation, captured something we had been waiting to see. Proof. Visual confirmation. Not anomaly, not artifact, not illusion. Real tail made of real ionized gas pushed by real solar wind, following real physics. The tail that reveals its true nature. 3I Atlas is comet. From another star system. Probably ancient, definitely unusual chemistry. But comet all the same. And that matters because in the coming decades and centuries we will find more. Each one will be different. Each one will teach us something. About their home systems, about their journeys, about how comets form and evolve in different environments around different stars with different elemental abundances and different radiation fields and different planetary interactions before being ejected into interstellar space. to wander galaxy for billions of years, until by chance trajectory brings them through our solar system, where for a brief moment we can observe them, study them, learn from them before they leave forever continuing journey that started before Earth existed. 3I Atlas tail visible from Earth, November 10th, 2025. Ion tail. Proof of cometary activity. Proof of solar-wind interaction. Proof that despite unusual chemistry, despite high carbon dioxide, despite strange nickel content, despite puzzling features, this is comet behaving as comet should. The tail does not lie. Physics does not change. 7 billion years old. Traveled unimaginable distance, carries secrets of ancient star system and interstellar medium. But still comet, still ice and dust and gas, still responds to heat and radiation and solar wind, still grows tail when sun heats it. The tail reveals everything, what it is, where it came from, what forces shaped it, and what laws govern its behavior. Same laws that govern everything in universe: gravity, energy, thermodynamics, electromagnetism. Universal laws, universally applied. Final approach, December 19th, then departure. Forever, back into the darkness between stars. Silent traveler, ancient messenger. 7 billion-year-old time capsule from somewhere else in galaxy. We got 5 months with it, July through November 2025. From discovery to perihelion to tail revelation to final observations. Short window, brief encounter, but enough to learn what it is, enough to measure what matters, enough to see the tail and understand. On November 13th, 2025, the Virtual Telescope Project published updated observations showing the ion tail continuing to lengthen and develop more structure. As the comet climbs higher in pre-dawn sky, over coming weeks, viewing will improve. More observers will capture it. More data will accumulate. Every observation adds piece to puzzle. Every spectrum measures composition. Every image documents activity. Every photometric point tracks brightness, all contributing to complete picture of this ancient visitor from unknown origin passing through our solar system for first and only time in human history, giving us chance to study something formed around another star, billions of years ago, carrying chemistry and structure shaped by conditions we can only imagine. The tail streams behind it, ion and dust painting trail across space. Solar wind pushes charged particles. Radiation pressure moves dust grains. Same processes that create tails on every comet ever observed. But this tail is special. This tail comes from comet that traveled across galaxy. This tail is made of materials formed around different star in different part of Milky Way billions of years ago. This tail is evidence of universal physics acting on ancient object from unknown origin. This tail is reminder that we are all made of same stuff, governed by same laws under same sky and same universe. And when amateur astronomer somewhere on Earth points telescope at pre-dawn sky in late November or December 2025 and captures faint smudge with faint tail trailing behind, they will have photographed visitor from another star system. Time traveler, cosmic wanderer, ancient messenger, 7 billion-year-old chunk of ice and rock and organic compounds ejected from parent system when our sun was young or not yet born, traveling through interstellar space for unimaginable time until trajectory brought it here to our neighborhood, where for brief moment we share space with something from somewhere else, something that formed under different sun and wandered galaxy alone, until chance brought it past our world, giving us opportunity to see it, measure it, learn from it, and watch it depart, knowing we will never see it again. But grateful for the 5 months we had together when 3I Atlas showed us its tail and revealed its true nature to anyone willing to look up.